Besides, applications of platinum in fuel cells. This is also the topic I will be exploring next. Due to length limitations in this issue, this time I'm just going to get a basic understanding of this kind of thing. More detailed production tutorial. I will do a new special feature on this. The layout uses a flat structure. Design style. It continues the transparent industrial style that has been popular in recent years. Because fuel cells require intricate gas flow channels, the concept is not suitable for integrated parts. Therefore, I used acrylic sheet lamination. The internal flow channels are built up piece by piece. It is bonded together by epoxy resin adhesive. I think the most painful step in the whole process it refers to dispensing and gluing. The whole process requires holding your breath, ensure hand stability, a slight tremor. This will lead to material scrap. Each layer of adhesive requires clamps for fixation. Wait patiently for it to solidify. Only proceed to the next step after confirming that each process is up to standard. Many sets of materials were prepared in advance. However, in the end, only 2 sets were barely qualified. However, there are still many flaws in its appearance. Let's just make do for now. This is the entire assembly process. The left side of the casing did not use a single screw. Instead, it is fixed by clips. Hydrogen gas is supplied via a separate base. The right side lever can control the power generation module. Secure. The protrusion on the left side fits into the main body of the fuel cell. Hydrogen enters through this point. I don't know if you've noticed a detail. Type A is actually a male connector. The reason is that I got carried away with my PCB design. Incorrect solder pads were used. However, this is not a big problem. Just be more careful in your next life. Therefore, I had to make a makeshift adapter cable. Everything is ready except for hydrogen. I will stick to the original plan. Sodium hydroxide reacts with aluminum to produce hydrogen gas. Note that this type of container should not be a regular beverage bottle. Sodium hydroxide can cause cracks to appear at the bottom of the bottle, caused leakage. Either use polytetrafluoroethylene or high-density polyethylene bottles. Place the aluminum block into the container. If you want to pursue higher gas production, use aluminum shavings or shredded aluminum wire would be best. Let's wait patiently for the power to climb to meet the operating conditions of DC-DC voltage regulator chips. In the event of a power outage, I threw some scrap aluminum into the bottle. This will provide power to my electronic devices. This is a hydrogen fuel cell. As of now, this device has very low power. After all, it is just a prototype. That is all I wanted to talk about in this episode. Hope this helps. Goodbye.